Excuse me. Okay. So on the first problem, of course, we discussed this last time. We talked about why you can't divide by zero. Okay. You can't divide 5 by 0. You can't divide any number by 0. You can't even divide 0 by 0. Okay. And the reason you can't divide 0 by 0 goes into the way functions behave. And it's really kind of almost a calculus idea. So we're not going to touch it. We're not even going to touch it in pre-calculus. What's for calculus? Why you can't divide 0 by 0. Some zeros are more powerful than others. Okay. I'll even tell you, 0 you get for the 1 over x squared function is more powerful than the 0 you get for the 1 over x function. Because 1 over x squared goes down to that, gets close to the x-axis much faster than the 1 over x. Okay, so they both approach 0, but this one approaches 0 more powerfully than this one. So we say divide 0 by 0. Well, if you're dividing this function by that one, yeah, the result could be 0. If you're dividing that one by this one, the result would be undefined. Okay, so now you know calculus. You can leave. You're certified mathematicians now. Okay, well, on to things. There's a reason. I'm just making the point that, and you can visualize the reason in terms of those two functions. But it's something you have to process a lot, and really, you're not in the position to process until the beginning of a calculus class. Okay. Pre-calculus gets you up to that point. Okay, so y equals 5 over x. You cannot divide by 0. Now you can divide 5 by 1. 1, 2, 3, 4, 5. You count to 5 by 1, right? You divide 5 by 2, but you get 2, 4, 6. You want too far, so it's somewhere between 2 and 3. Well, it's 2.5. 5 divided by 2, right? Okay. 5 divided by 1/2. 1/2, 1, 1.5, 2, 2.5, 3, 4.5, 5. That was 10. If my working memory is strong enough to remember that I'd been through my hand once by the time I got there. Okay. Okay, so now you want to divide 5 by 0. How many zeros does it take to make 5? You can't make 5 out of zeros. 5 is something, zeros kind of like nothing. You can't make something out of nothing. You make nothing out of something because you can multiply it by nothing. No, you multiply a number by 0 to get 0. But if you divide a number by 0, you sure don't get 0. It takes a lot more than 0 zeros to make 5. Okay, so trying to convince you can't divide by 0. That's important. Okay, well, what about this one? What you know is the denominator can't be 0. So that's one of your principles. Okay, and square root of a negative number isn't a real number. So if we're talking about functions that give you real numbers, what's under the square root sign can't be negative. Okay. So you want to do the square root of whatever. whatever has to be greater or equal to zero. If it's less than zero, it's negative. You can't take the square root of a negative. Okay, you can, but it's not a real number. You get an imaginary number. We did a little of that, I think, with quadratic. Okay, the I thing, we do that? Is that something? Sometimes I lose track of what we've done here, and what we've done in next class. Okay, that's it. Okay, so see if you can reason this one out, and then see if you can reason this one out. Okay, so the little switch you gotta turn to apply this to this. Okay, so let's say you have 5 over x minus 7. Okay. Well, the denominator can't be 0. Okay. What's the denominator? Don't tell me yet, but. Okay. What's the numerator here? It's 5. What's the denominator? It's x minus 7. Got a numerator, got a denominator. Okay. Terminology might be thrown aside. Okay. When I say the denominator can't be 0, I assume you know what the denominator is. Okay. So let's be sure we understand that. When you have something divided by something else, the denominator is the thing you're dividing by. Okay. Fraction has a numerator and a denominator. So the denominator can't be 0. So what is it that can't be 0? Don't tell me that. Okay, well, yeah, the denominator can't be 0. So what can't be 0? Well, x minus 7 is a denominator. Let's learn another step. Denominator is x minus 7. So x minus 7 can't be 0. Now we can write that as an equation. X minus 7 is not equal to 0. Not equal is an equal sign with a slash there. Okay. We can add both sides. Add 7 to both sides. X minus 7 plus 7 is not equal to 0 plus 7. If x minus 7 is equal to 0, and x minus 7 plus 7 is not equal to 0 plus 7. So x can't be 0. That makes sense. Now, I'm going to give you another one. I want you to write out all these steps. If at least you got it now. Some people got it, but most people didn't. If you write out all these steps, tell yourself what you're doing and why you're doing it, then it should make sense to you. It should begin to make more sense. So let's try. Eight over 3x plus 9. Okay. Now, write out all my words here. But instead of x minus 7, you're going to write this out. Write out all the words. Even if you got it, I think it's gonna be good for you to have this in your notes, where you write out all the words. Okay, so if you write out this whole sequence of steps, write out the words so that you process the meaning of what you're doing rather than just write it out without really processing the meaning. Okay. That didn't make a lot of sense. Write out these words, it'll help you process the meaning. If you write out the words in this one, just go ahead and do it. You got y equals 8 over 3x plus 9. Denominator can't be 0. Identify the denominator. Denominator 3x plus 9. 3x plus 9 can't be 0. Written as an equation, actually an inequality, or a non-equality. And I just copied down what I had there because thinking about what to say and writing down a reflex. Three x plus 9 isn't 0. That's a really bad 3. Well, that means then that 3x plus 9 minus 9 is not equal to 0 minus 9. Now, at this stage, the majority of the class wrote x can't be 0. That doesn't follow from this equation. This is just like an equation, it's a non-equality. Okay. 3x plus 9 minus 9 is just 3x, because 9 minus 9 is 0. And 0 minus 9 is negative 9. Just like solving a linear equation. Three x over 3 is not equal to negative 9 over 3. And 3x over 3 is just x. So that's not equal to negative 3. Okay. Now our conclusion is the domain consists of all values of x except 3. Why is that? Except negative 3. Sorry. Why is that? Well, if you put negative 3 in here, you get negative 9 plus 9 in your denominator. What's negative 9 plus 9? Okay. And you can't count the 8 by 0. Okay. So that's it. Now there's a way you write out that domain. If you do the problems, you'll see that I'm not going to take class time to do that, because the key thing to understand is set the denominator equal to 0. Solve, get everything you exclude, or set it not equal to 0, and you get what you need to know. You get the numbers that you can't put in your denominator, so they're not in your domain. So you can write this out. Domain is all values of x except negative 3. Down here, domain would be all values of x You know why you guys wrote that down? Probably it's because you're imitating what I did. I wrote something down that made no sense at all. I wrote 0 down here instead of 7. Okay, and that misled you. I apologize for that. That was a real bad thing. X can't be equal to 7. Here, X can't be -3. So I thought you'd lost your minds about the algebra when you were just imitating the person that had lost his mind about the algebra, okay? Just wrote it down very carelessly. Yeah. That was a bad thing to do. Okay. Consider y equals the square root of x plus 11. You can't take the square root of a negative, at least if you're talking about real numbers. Go to complex numbers, sure, you take the square root of any complex numbers. But you can't take the square root of a negative. So x plus 11 can't be negative. Which means it has to be greater than or equal to 0. Yeah. Okay. So come up here. And I'm probably off of the camera. I'm still there. X plus 11 is greater than or equal to 0. How do you solve that? You solve it just like you would an equality. X plus 11 minus 11 is greater than or equal to 0 minus 11. And now, I relaxed over here when I got to that point and wrote down something totally wrong, remember? I'm not going to relax. I'm going to try to keep my attention on what I'm doing until I'm done with the problem. Okay, I should know that by now. So we have x is greater than or equal to -11. Okay, so it means all real numbers greater than or equal to -11. And I'm going to do a picture of that. Here's -11 on the number line. X can be -11. So I'm going to put a big dot here, show that -11 is included. But sometimes it isn't. If this is a greater than rather than a greater than or equal, it wouldn't be this problem, but if it was, I wouldn't have a big closed dot, I'd have a big open circle. That's something that I'll let open math show you. Okay, right here's a picture. This is your x-axis. Right here's -11. And all numbers, including -11, on this blue, on the blue line that's defined by this blue arrow. This blue arrow means you keep going forever. Okay, it's like this arrow here on the x-axis means you keep going forever. So your solution, any x value here, 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 any x value anywhere in the x-axis, as long as it's here or to the right, works just fine for this expression. Okay, so for example, x equals -10. If x is -10, what do you get? Show me your fingers. X net plug in -10 here. Yeah, you get 1. Okay. -10 plus 11 is 1. And the square root of 1 is 1. Okay. Now, if x is -9, then you got the square root of 2. You can't show me that with your fingers. You don't have enough fingers to do a decimal representation of that because it's infinitely long. Okay. An irrational number. Well, there we have it. Can you take this and imitate those steps? Write them out and solve this. Find the domain of this one where C is your number. If you don't remember what your C number is, I'll go back and find it, or I'll give you some new numbers. But right now you can make up any number you want. Okay, function notation. Let's say y equals 1 over x, but I want to give this thing a name. Its name is going to be f of x. And this is the first time I've officially used the word function. F is the name of this, and I also put it in quotes, but it doesn't usually go in quotes. Okay, so this is what we call a function. Okay, this function has a graph. And we know what the graph looks like. Here's x. And the y-axis, we'll say y equals f of x. So your y values are your f of x values. Now, what do I mean by f of x? I'm throwing that term around. Get this pop up off my screen. Okay, function has a graph. Looks like that. Okay, so what is f of 2? Well, we're going to answer that question in a very obvious way. Well, f of x equals 1 over x. Said that. They better believe it. Or not. That's what f of x is until we change our mind and f of x becomes something else. Okay. We talk about it differently. F of x is 1 over x. So f of 2 doggone well better be. Well, if I write f of 2, that means x has to be 2. If x has to be 2, then doggone it, f has to be 2. Okay. So if f of x means 1 over x, f of 2 means 1 over 2. Okay. Okay. F of 18 has to be 1 over 18. F of negative 1/4 has to be 1 over negative 1/4. Of course, you got to do the arithmetic, that's negative 4. Okay. And even f of aardvark is 1 over aardvark. Now, I don't know what the reciprocal of an aardvark is, but that's what f of aardvark has to be. Okay, but aardvark probably isn't in the domain of f. Okay. Now notice, I can talk now about the function because I gave it a name. Okay. And I want to talk about this function. It's a little easier to talk about the domain of f rather than talk about the domain of y equals 1 over x. It's just less writing. And if it's a big long function, you know, x plus 5 quantity times x squared plus 3x minus 7 quantity over x plus 8 quantity times quantity x squared plus 17x minus 9. Okay. I don't want to have to write that out every time I want to talk about that function. I want to give it a name and I want to use its name to refer to it. Then I can say, okay, what value of x is f of x equal to 0? Rather than saying what value of x is f equal to quantity x minus this and x squared and all that stuff. I don't have to write all that out. Okay. So there's a good reason I've been able to talk about functions by giving them names. It's just a way of giving them names. And the way the rule is simply, once you write the rule for the function, then you put any number in here, x, replace x with any number throughout the whole definition. Okay. Okay. Now, x, if g of x is 1 over x squared, what is each of the following? how much of that you can get. Down there toward the end, it starts looking a little weird. Okay. Okay, y'all did real well with that. Have to write it out here again. Move that board over to the left, but we have. G of x equals 1 over x squared. So. G of 2 is 1 over 2 squared. G of 1/2 would be 1 over quantity 1/2 squared. G of 0 would be 1 over 0 squared. Which is undefined. 0 is not in the domain. Of G. And then G of P plus Q. One over the quantity P plus Q squared. Because of course, it's X, it's being squared. So if X is P plus Q, it's a whole doggone P plus Q gets squared, and it wouldn't be if you didn't put the parentheses around it. You just wrote P plus Q squared with no parentheses, Q would be squared, but P wouldn't. Okay. And certainly P plus Q would be squared. Now, one other thing is, squash up word there is provided P is not equal to negative Q, because if P was equal to negative Q, what would our denominator be? 0. If P was negative Q, you'd have negative Q plus Q, and have 0. Okay. So you kind of want to make note of that. Domain can be a very important concept. And there's also the concept of range, which I'm not talking about, but open math will. Hopefully you pick that up. Right now, just get you a head start in pre-calculus. I'm going to be content to have you just master the idea of domain. Range can be a little tougher for some functions. But if you got domain down, then when you get into pre-calculus, you're going to be able to focus on range, not have to worry too much about domain. And you won't be stumbling over domain if you really like this one. Okay, now there's another thing that comes up in the first couple of weeks of pre-calculus, which is compounding functions. So without using that word, we got our f of x here. We've got our g of x here. First of all, what would f of q of z be? I'll do g because we just did g. That was fresh in your mind. What's g of q of z? That's a q. This is a g. And this they might look kind of similar. Okay. Just follow the pattern of what we just did and write down what you get. Well, g of x is 1/x². The g of q of z is better be 1/q of z², right? Whatever's in the parentheses on g is going to be your x. That's going to be your x. Now, yeah, hang on. And I'm not sure. Okay, so the question, why is the q of z all in parentheses? Well, it could be. And probably I should have done that. Okay. Q of z squared without parentheses means the same thing as it does when it's in parentheses, but you wouldn't know that. So I really should have put that in parentheses, and so should you. Okay. Okay, well, what I want to say is, okay, so what's now L or G of f of x? Write it out. G of f of x equals. Yeah, put the square outside of it. It's actually correct either way. But yeah, okay, now I think everybody's got it. Steve got it. Okay, well, you're going to get it. You got the one before. Yeah, lock that in because it's going to be very helpful to you.